Alright, in these sections we are going to discuss about how deep learning works, okay? Deep learning network works, okay? So this is the input layer we have. This is a kind of 5-layer neural network, which we have one input layer, one output layer, and we have 3 hidden layers, okay? So as a part of these discussions, we are going to learn how deep learning networks works by saying that how it is working, how the training process works, okay? So we have 4 neurons, 4 basically input contents, and we are passing those inputs to each and every individual neurons in the first hidden layers. They are doing the calculations and they are creating the output from their activation layers and passing those values to the next layer, to each and every individual networks, individual neurons. Similar to the previous layer, they are also calculating the activations output and passing those contents to the next layers, to each and every individual neurons. In this way, this content is being passed till the final layers, the output layer, which is basically creating the probability distributions in which particular class the input is belonging. Okay. So initially, what we'll have a set of inputs, and we have a kind of layer level that is called output. Okay. So alright, x and y is already given. On the basis of that supervised basis of this input, we are going to do a supervised training process. Okay, so we'll initiate the values for weights and biases randomly. We have different advanced mechanisms to initiate those weights and biases. We'll discuss it later in the component understanding class. So as of now, just assume that we're going to initiate those weights and biases pretty much randomly, and we are going to calculate during our first executions. Okay, so we'll multiply the inputs with the randomly initiated weights and biases in the first layers, and we'll create the activation output. We'll pass those contents second to the next layers. There also we'll multiply it with that particular layers randomly initiated weights and biases, and then we'll do the calculations for activations. Then we'll pass those contents to the next layer, and so on till we are producing the first output. Okay. So once it got some output, then what it is going to do, it is going to compare the actual input, output with the predicted output. Okay, and on the basis of this comparison, they are going to create the errors. We have different mechanism to kind of calculate the errors. Maybe sometime that is root mean square or root square square mean error. Similar sort of things, or maybe categorical cross entropy or binary cross entropy, and similar sort of things. Many concepts are there. So for now, you can kind of skip those content. I promise you will have complete understanding about them in our later videos. Okay. For now, these output layers will have some calculations to understand, okay, I'm doing these predictions this much with this much incorrect values on average, so that error values will be sent backward. Okay, the error things will be sent backward. On the basis of that error, it is going to do a small adjustment for those weights and biases in that layer. Okay, again that error should be sent backward. The next layer should be adjusted accordingly. Small amount of weights and biases changes, and so on till we are reaching to the first hidden layer. till we are reaching to the weights and biases for the first hidden layers. Okay. Now we will train it once again on the basis of, we do the calculation once again on the basis of the newly calculated weights and biases, and we will again follow the same process to produce the final output. Once again we are going to compare the predicted values and with actual output values, and we'll calculate the error amount, and we'll send those error values backward to do the adjustment once again. Similar to this, we will do this process many times till we are getting optimized neural network. Why I'm saying optimized? Because later we'll understand some trade-offs and concept between bias and variance, basically, to reduce the overfitting and all these sort of things. So finally, when our model is completely trained and we are satisfied with the training process and the validations and basically the errors, final errors, so we can stop our model and we can kind of have the final weights and biases. So when you are going to get the new input values, maybe that is something different, but we'll have the same structure for the same data content. There you will not have any output values basically for your reference. So you have to multiply and do the calculations on the basis of the previously trained weights and biases for each and every individual layers till you are getting the predicted output. By this time you will have confidence, okay, I am doing this calculation, so I am 95% sure that I am going to produce the right predictions for those inputs, and your network is ready now. Okay, so these individuals are neurons, as we already discussed, but in real life challenges you will have to use most of the cases like those advanced neurons, something called ReLU or TANG or sigmoid sort of things, to have the optimum result. Okay, this whole concept, when we are producing the output first and then we are sending it to backward the error rate and training those individual neurons or adjusting the weights and biases accordingly, this whole concept is called backward propagation. Alright, so how much adjustment we are doing with the bias and weights, that depends on some concept called learning rate. Okay, so learning rate is something, let me write down the term, okay, for you. Alright, so alright, so this particular value will say how much adjustment you are going to do on the basis of the error you are getting. Okay, for each and every layers we have different advanced mechanism to adjust the learning rate during this training process. Okay, we have second order learning rate as well, depending on the momentum, how we are doing the training and how good we are doing with the training process. Alright, so normally for the classification models, we'll do a probability output for if we have multiple classes. Okay, like if we have 1, 2, 3, 4 different classes, and you need to predict which class own that particular input values. So you will get the output like the probability of that content to belong to a particular class A is class 1 is 0.1, next one is 0.2, so the third one is 0.7. That means we will consider that the third class is the actual output for this actual predicted value for this whole input value or kind of test or maybe the final data. Right, this is pretty much how it works, and these bias and these different biases, those are kind of very similar to the threshold or theta, whatever you understood. Those are in machine learning term, those are called biases. Okay, so pretty clear about it. So I hope you have understood this whole concept, like how deep learning works, pretty well. If you have any doubt, then we can kind of you can leave some comments, and I will individually clarify all those doubts whatever you have. All right, so okay, so let's move to the next section, okay, where we are going to discuss about several key components of deep learning, basically the bricks of deep learning which you are going to use later to construct the whole deep learning architecture. Okay, and bear with me, that is very crucial for your whole understanding. But once you have complete understanding of all those components, okay, so it will kind of feel very easy to understand the next set of advanced concept related to the deep learning frameworks. All right.